Hi, it's little Andy back in the cave. It's been a while, but had a few projects on the go. Just wanted to show you the most recent thing that I've been working on, which is an annealing machine for brass when you're reloading your bullets. Stuff like this, obviously. Most people who'll be watching this will know the whole principle behind it, but for those who are just curious about it, when you shoot a bullet out of your gun, the brass work hardens, and to extend the life of your brass for when you're reloading, and some people say for consistency, so your neck tension on the bullet is consistent for better grouping by the target or hunting. People say anneal your brass, gives you the consistency, extends the life of your brass, and to do that, there's two trains of thought. Is basically to anneal the brass, like a lot of metals like steel, you've got to heat it up. Historically, the way people would do this with flame, open flame. Some people have developed machines which the bullet passes through a flame, warms it up to a certain temperature, anneals it. Recently, there's been obviously induction coils have become more prevalent, and there's a few systems on the market that use induction coils. So I've built my own. I've taken a few ideas and a few guides from a few other things that people have done out there. I've done it slightly different to the way other people have done it. Maybe better, maybe not. Let me know what you think. It's definitely quick though. So we'll break this up. I'll do a couple of things on, we'll have a look on the inside, we'll have a look on how I've done it, the way it works, we'll watch it running, and the whole sort of theory behind it. So starting with the internals and what it's all about. If you're wanting to make something like this yourself, bear in mind it doesn't have to be as complicated as this. It's a fairly simple thing, and obviously, as with everything I do, I tend to take a little bit further than you need to. So basically, you've got a power supply here to run the ZVS. We'll come on to that in a minute. Power supply is taken out of a cheap arc welder that you can buy. It's a 150 amp power supply. This then runs the feed for the ZVS with the zero voltage system, which is basically it takes the huge amps output from this, turns it into a super high frequency output, which that output high frequency current then it runs through a coil on the front. Because it's run a high frequency, it induces a magnetic field. That magnetic field then reacts with a metal that's inside the coil and causes it to get hot. Depending on what the metal is, you tune the coils to different frequencies. You know, sort of about 70 to 80,000 hertz is good for brass. 60,000, the slightly lower side of it, is better for steels. Obviously, we're doing brass, so I've tuning it, and by tuning the coil is dependent on the number of turns and the diameter and the length of the copper coil is what causes the frequency to change. There's far more clever people than me out there who've done endless calculations on working out the coil sizes, even online calculators to work out the size of your coil, the number of turns, the number of wraps, how many layers there are to get the frequency that you need. So ZVS is just a cheapish one from China. I got that from Aliexpress. Most of the induction systems out there are running at around about 1,000 watts, which is more than enough to warm up your brass. This one is a 3,000 watt, because why not? From there, I've then got a comprehensive cooling system, Thannks flow, external pump, which then runs through a radiator, an additional radiator here. We've got fans, case fans on the top, front, bottom, extra fan for the power supply. The ZVS has got its own fan, and two fans running here which go straight to the radiator. which not only keeps the inside of the case cool, but the cooling system runs through the ZVS. It runs through the coil on the front to keep the coil cool. If you're doing short runs, you could probably get away without water cooling, but when you're running higher power like 3000 watts, and if you're doing a lot of brass, it can get warm, so cooling system's worth it. On the inside, we've then got a board which runs the electronics for the hopper system and the gate, which we'll come on into a second. Got to thank my friend Stig for that. On the front, we have a hopper system. So let's move it up a little bit to see that, which takes the brass on the top. We've got a wheel here which feeds it around, depending on the size of the brass that you want. These are magnetically popped in, so this size does 308. Same size around. There's a guy who's MGMZ Makes, who basically came up with this system of the hopper on the top. He's done it slightly different. He uses a single one with 3 different hole sizes and a sort of a guide to let you select which hole size you want for the size of the brass. That works, but by doing it this way, that's got to do a full rotation of load around into the hopper. This way, that set does this size of brass and everyone can be loaded, and which means it's only got to rotate slightly to drop the next one in, which means it loads much quicker. And for different size brass, this one does 4570, but to be fair, there's a huge overlap on, I know this says 308, but 308 does, what is this 223, I think it is. I think it's, can't see that, my eyes are rubbish. I think it's 768, it's a military round. 260 Remington, 308, 223, loads of stuff fits in that one. 4570 does 4570, obviously a much bigger round, but it also fits like a 300 Win Mag, things like that. So although it's got those names, you probably will need maybe 2, possibly 3 to do pretty much everything you want. There. MGMZ and a lot of other people who followed his way of doing it they've do a servo motor to drive this with a feedback loop. So basically, once you turn it on and have this set in a position, it then rotates a predetermined amount to load the next one. Because it's got feedback, it knows if it's jammed and it's losing steps. This way is done differently. This way uses a standard stepper motor with no feedback, but inside the side here I've got a hall sensor. The hall sensor picks up the magnet on the side, so that knows when it's reached. It means that when I start this off, it could be anywhere and it'll find the next position for the magnet. It knows when it's turned to ignite the coil, if you will, and then it rotates until it picks up the next magnet. Advantage of that is the circuitry on the inside is far simpler, and the standard stepper motor without the feedback and the circuitry that goes with it is also cheaper. Obviously, I've done this really cheap and cut corners, but no, seriously, if you're doing it yourself, by doing it this way, and you want to do it simpler without all the excessive gubbins on the inside, it does keep the complexity and the price down as well. From there, once the bullet drops in here, there is a set of eyes inside this unit here. Now, a lot of people run it where it's on a timer, so once it's dropped down, it'll time it, then it'll open it. The way this does it, it won't, once this rotates, the round drops in, the coil will not fire up until that's detected there's a round in it. Once that's detected a round is fully seated, it then starts the coil. It runs through the predetermined length of time to anneal the brass. Once that's complete, the gate opens, the brass drops out. The eyes then know that the gate is clear, that it has cleared. It will then shut and load the next round. If for some reason something jams, or this doesn't clear, it won't load the next round until that's cleared. So it's kind of a safety factor there, so nothing jams up. It also detects that if this rotates, nothing drops, it'll rotate it again. If nothing drops, if this will rotate again, nothing drops 3 times in a row. It then determines that there's either a jam or it's empty, and the cycle's finished and the machine shuts down. On the other side, to control the magicness, also part of the gate for different size brass, you've got a height adjustment here to set where you need the brass to anneal, just so you do the correct area. Anyway, we've got 2 laser cut panels here to control systems. One's for the main power, and the second, lower one, is to control the ZVS and the gate and the eye system. So we've got the main power here, we've got power for the cooling system, we've got power for the coil if you wanted to override the system and just make some metal hot, because you love making metal hot. We've got the power supply output from the welder supply, and I've got that adjustable from it's about 20 to 150 amps. The reason I've left the adjustment on there, because depending on the coil and the brass, sometimes there seems to be a little bit of the ZVS doesn't settle properly. It's the relays inside seem to twitter a little bit, and by just fine-tuning the input power seems to settle that down. On the gate control, we've got the power on there, we've got a start button, reset button, we've got your time control for how long you want to anneal your brass, and we've got a coolant temperature here, and obviously we've got over temperature sensors and stuff like that inside to keep everything nice and lovely. This is all on switches and plugs, so everything can be disconnected and taken off for cleaning, or if you just wanted to use the coil to melt stuff. We'll power it up, have a look at some stuff inside. Power that up. So we've got annealing time from 1 second to 9.5 seconds, which is more than enough. I've found that the kind of depends on the size of the brass, but the 4570 about 1.6 1.7 seconds, 260 ramped, and I think the brass wall seems to be a bit thicker, plus it's a bit narrow at the top. That's like 2.5, but you can drop one in and fine tune it. You'll find that there's not much difference in it. Like I say, the 4570 1.7 seconds is enough. 1.8 1.9 seconds, which is only back again 0.2 of a second more. Kind of, it doesn't work. It makes it a little bit too hot. So 1.7 is about the maximum you can get that. But to be fair, like I say, with the 3 kilowatts, you're annealing brass in less than 2 seconds, so it cycles fairly quickly. I'm going to set that back up to 6. On the other side, inside here, we've got some internal lighting because why not? And we've got the cooling system pumped around. We'll pop the side on in a second, and let's see it working. Okay, I've got it loaded up now. I've got about, I don't know, 20 brass in there just stuffed in. Cooling system's running. Let me peek over this side. Try not to make it too dizzy. We've got it set to, I don't know if you can see that, 1.6 seconds, which is probably a little bit low. Let's go 1.7. Cooling system's running. And let's get you somewhere you can see it. I've got a very, after all this technical stuff, I've got a glass jar and a small plastic pot to go underneath it. You could have it drop it into water, to be fair. One thing that there's a bit of, people say that you can't quench your brass because obviously it'll harden it again, and defeats the whole point of the annealing process. Well, that's a load of rubbish. Brass isn't like steel and the carbon steels where thermocycling, annealing and hardening can be done by quenching, cooling, things like W2 steel, which is designed to be water quenched to give it the hardness. Brass doesn't work like that. The only way brass hardens is by work hardening, and getting shot in a gun, the expansion of the gases work hardens it. It's not the heat or any of the cooling that does that, it's the work of the metal which hardens it. brass is a single phase alloy, and when it's single phase alloy, basically there's a lot more to it, but essentially it only hardens by work hardening, not by the cooling or warming of it. So once the brass is heated, it anneals, but quenching it doesn't harden it. It doesn't affect it by plunging it into cold water, because it's a single phase alloy. The only process that can change the hardness or softness of the brass is the temperature, the warming of it, and it only hardens by work hardening, not by the rapid cooling. So you can essentially drop it into water if you want. Obviously you're going to have to wait till it dries before you can reload it. So let's make it, can you see that nicely? Let's see if we can get a bit of view. We'll zoom in, so we'll start that there. It's going to find its first point. Let's see, a little wisp of smoke is if you've got lots of brass people, this is the way to do it. I know AMP has a new system out where it's got a hopper. It looks very, very complicated to set up. This, fling it on the top, press go, makes stuff hot. I'll get a bit of a closer here how the gate working. Let's see if we can drop you down and see the gate a bit. Drop you in there. Finished. Let's. Well, this is essentially the gate here. But fake a bullet in there. Let's get that one. Sorry about that. Stick that in there. Obviously all this section's 3D printed. Like I say, this top section, the hopper design is from MGMZ Makes. It's been modified slightly to make it, tweak it to what I wanted, and obviously this centre section has all been redesigned to fold the multi-bullet system in there. Zoom a bit close up like that. Obviously it hasn't picked up any rounds for a second, so that beep means it's finished cycle and it stops running. And we've got a jar of hot brass. Okay. So that was the system working. Last little piece is, obviously you go through all this kind of thing. I know there might be some comments like, can I buy one? No. There's a lot of electrical death in there with the 150 amp power supply. I mean, it is safe. There's a lot of safety features built into it. But for me to sell that unit onto somebody, the amount of hoops I'd have to jump through, and there would be extra protection, extra containment. I would have to have it tested and CE marked and all that, and that is just not a road I want to go down. If you want any questions, answer, advice on how I built it, by all means ask me. Everything is pretty much off the shelf. The ZVS, you can buy that. There's a few different sizes you can buy. You could go and get one from China, get it imported. You can get one for as little as about sort of 40 quid, and then from there you could spend up over, depending how much, I mean, you could go nuts, spend a few hundred quid and build yourself a 10 kilowatt one. That would be sweet, and if you do, send me a video because I'd love to see it. The power supply came from a welder that you can get on eBay. It was the kind of welder, like an arc welder you could buy in Aldi for sort of 40 quid. You basically pull that to bits, you stick that in for the power supply for the ZVS, and between those two things, that's pretty much all you need. The ZVS comes with coils. You can adjust them to make the right one for the frequency you need for the brass. The ZVS generally comes with not very good, but a cooling system, and that would get you going. If you've got a 3D printer, the rest is, you know, doable. If you haven't got a 3D printer, MGMZ sells sells them on his website, all these bits. The only thing that you would struggle with is the way I've done it. I mean, the way he's done it would work, but if you want to do it super fast and do it the way I've done it with the separate units for the different brass, give me a shout. I'm sure I can come up with something and do it. The circuit board that control. Let me turn this up so it's not that controls the gubbins at the top and things like that. That I could sell because it's low voltage. It's basically a plug and play board where you give it your 24 volt input, and then you've got outputs. Which is basically like a dry contactor, ignite the ZVS board, and then you've got a couple of inputs to control the hall sensor, the servo for the gate, and then the stepper motor for the wheel at the top. I'd consider making more of them and sell them, and then everything else is pretty much off the shelf. But no, I'm not going to go down the road of making these. The next thing is obviously you've gone through all this effort. You've got some brass. You've made it hot, and it's too cool down. Still hot. It's all nicely cremated on the top. I mean, you can tumble it. These have been annealed. Once you've tumbled it again, it comes up lovely and shiny again, so that's no problem. But obviously you've gone through all this effort. You've made your brass hot. It's gone cold again. Was there any point? There's no point in doing this without proof that it's actually doing something. It's all very well. There's a lot of people out there who will stick these in the little flame gun. They'll get a blowtorch, make it hot to a temperature which they don't know, or they'll make something like this. But unless you know that it's actually annealing, it's kind of a bit pointless. So this was stumbled on because of a guy. There was a RussDouglass's channel, and there's a guy in there who's, again, to be fair, hats off to him, a guy called Bruce, who built his own induction coil powered annealing machine. I've taken it a little bit further than him, but don't get me wrong, he kind of set me off down the rabbit hole. He's an electrical engineer or something like that. He knows far more about the internals than I do. I've kind of bumbled my way through, and I've got a mate who did the circuit board. So other than cobbling things together, putting the cooling system in and making the 3D printing stuff, and most of the stuff, he put us on to proof that what you're doing is actually doing something. So there is various hardness testers out there. There's Brunel's, Vickers, Mo. But a lot of them are very expensive. And he mentions this thing, which I found. It's called a Webster hardness tester handheld. If you look out on eBay, places like that, don't buy a new one, because they are, for what it is, stupidly expensive. I think for a new one, you're looking at something ridiculous, like somewhere between £300 and £900. It's just mental. So keep an eye out for second-hand ones. They come up. Brucey got his very cheap, new on Amazon. I think that was a fluke. I got the second-hand. I ended up getting it shipped over from America. I took a punt on it. It was listed as £45, including shipping from America, because it was faulty. It turned up in its original box with its original test pieces, instructions. It turns out there was nothing wrong with it. It just needed calibrating. And to calibrate it, I followed the instructions that came with it and used the test pieces that came with it, and it took us about 10 minutes, and lo and behold, it works. So that's Americans for you. So basically the way this works is it's got a little anvil, a little thing, and a gauge on the top, and when you press it, zoom in there, let's see if we can see that, use a little needle moving, and it bottoms out, and when you put brass in there, it gives you a reading for hardness. Now there is scales for this, which then converts it to Vickers and Brunel and all the other things if you want, and this one. But to be fair, you don't really need to know what the scale is relation to. All you need to know is that if you've got an unshot case, like if you bought some Starline brass, actually Starline's a bad example on 4570 because Starline 4570 comes actually unannealed, so it's actually harder. So if you bought a different brass from Hornady or something like that, didn't shoot it, you could get a reading off that, and you would know what annealed brand new brass is. Say it gives you a reading of, I don't know, 7. You shoot your brass. This is shot brass that I haven't annealed. Obviously, one thing I had to do, there's a little anvil at the bottom. That's much bigger. You've got to grind the crap out of that to make it thin enough to fit inside a bullet. Other than that, it's fine. Once you've shot your brass, like this is the same, whatever this is that I've been using, and this, squeeze it where it is, like that. I'm pretty sure I haven't had this through the annealer, so this is going to make me look stupid if it doesn't come up. What's that come up there in the middle, which is 9. And this is the stuff that I've just put through the machine. Yep, it's cool now. And that comes up with, can you see that? Yeah, let go. What's that? 5. Half as good. What it was like when it was new, I don't know. But that to me is annealed. You can play around with the settings to see if you can, if you really need to wring the last millisecond of annealing out of it. You know, that fraction of a second before it turns liquid. As to whether you need to take it that far. But the way I dial it in is I basically run some brass, creep it up until I get that liquid stage, and then back it off by a couple of milliseconds. All seems good. That's pretty much it. Let us know what you think in the comments, if there's any interest, if you think I've done something wrong, if you think there's any improvements I could do with it. And if you know of something, an anneal machine that can anneal brass faster, send me a link, because I'd like to see that. Give me a challenge to beat that as well. Woohoo! Thank you very much. See you soon. One more little note, just to nip in on the end. If you do look for a Webster hardness test and you want to go out and buy one, there's a couple of models. I don't want you to waste your money, so make sure you get the model that is in the range for brass, because you get ones which are specifically for like aluminium, steel, brass, and this one is the B. Oh my god, what does that say? My eyes are terrible. B53? B75. The B75 is the one that you want for brass, I think. Tell you what, I'll zoom in. Can you read that? Can you read that? Your eyes are better than mine. Should put my glasses on. Thanks very much. See you soon.